question number 3 from the 2018 AP exam. And if you notice for this one, what they've given us is a graph, which probably means some sort of area problem here. And they say that this is the graph of the function g. And whoops, sorry, and g is the derivative of f. Sorry, 10. There we go. So they're telling us that g is the derivative of f. And g is linear from -5 to 3, and g is equal to this parabola from 3 to 6. Now the very first question, oh my gosh, there it is. They threw it right off the bat for us. They're looking for an FTC. Because this is f prime, they want the value of f. So this is our FTC. This is like the 3rd time in a row. Question 1, 2, and 3 all have this. It's like they want you to know this stuff, right? So I'm going to integrate this from -5 to 3. I do like to go into order. F prime of x dx, and that's going to equal f of 3 minus f of -5. So we have to look for the area here. And I'm sorry, this one is going to hurt. So from -5 to +3, I'm looking for all of this area right here. So I'm going to break it down. I got a rectangle, I got a triangle, I got another triangle, and I got a rectangle again. Now be careful. Anything below the x-axis, don't forget, it's negative area. Anything above the x-axis is positive area. So when I start this, my first one is going to be, it has a rectangle. It's 1, 2, 3 by 1, 2, 3. Oh, that's nice. So it's 3 by 3. But remember, it's going to be negative because it's below. Minus this triangle, too. Again, it's below, so it's minus 1/2. Base is 1. The height is 3. Plus, see, now I'm over here. So now I'm right here. So now with that area, that's above, so it's positive. 1/2, 1 by 2. Plus, and now I want this rectangle right here. Again, it's above, so it's going to be positive. 2 by 2. There we go. And that's going to equal f of 3 minus f of -5. And if we simplify all of this, we would, if we want to solve for f of 5, we simplify, we would get -9 minus 3/2 plus 1 plus 4 equal to, and remember f of 3 they're telling us was f of 3. That should be f of 1. Anybody fix that for me? That should be a 1. Doesn't change anything. There we go. F of 1 was 3 minus f of -5. I'm just going to be too lazy to start over from again. It's like the 3rd time doing this problem. I'm not doing it again. All right. So if I want to solve for f of -5, I have a couple of options I can do here. One, I could just bring over the 3. I will get -9 minus 3 over 2 plus 1 plus 4 minus 3. Now that's going to equal negative f of -5. So there's 2 ways you can fix this. One, I can be really super lazy, just make that a plus and make that a minus. AP is cool with that. I'm okay with that too. Or we can just say what it is, f of -5, the 3 there, man, I'm being terrible with this one, equals 25 over 2. And that's your answer. You're going to get 1 point for your FTC. Show that. 1 point for your answer. All right, so let's go to part B here. Part B. Now it's to evaluate g of x from 1 to 6. So let's go back over here. Remember, g of x is my area. Now I want the area from 1 all the way to 6. But again, I have to split it up here at the 3 again. So I'm looking at this area, this rectangle, plus the area underneath this parabola here. So I'm going to split this up. So my first integral is going to go from 1 to 3, and that's going to be g of x dx plus the area from 3 to 6, g of x dx. Now the area from 1 to 3, that's just that rectangle. Let's take a look at it again. That's just at this little rectangle right here. That's just 2 by 2. 2 by 2 plus, now this right here, though, I have to actually integrate. This is the integral, remember, sorry, the area, under the graph of this parabola, 2x minus 4 squared dx from 3 to 6. And if we evaluate this, we're going to get 4 plus, if we integrate here, you can expand that if you want to, or you can just use kind of like a u substitution, where u is just x minus 4, but this is a quick one. That's going to give us 2/3 x minus 4 cubed, and we're going to evaluate this part from 3 to 6. Now be careful, this is a whole other problem. That 4 is independent. So we would get 4 plus, and then doing the f of 6 minus f of 3 bit. Let's see here. Plug in the 6. Let's see what we get. 6 minus 4 is 2 times 2, so that's going to give us 4 thirds cubed minus plug in the 3. That's going to give us negative 1. That's terrible. That's 2 cubed, 8 times 2. That should be 16 over 3. Sorry about that. Forgot to cube it. Bad algebra. All right, so if we plug in the 3, 3 minus 1 is negative 1. Cube negative 1, you get negative 1, so that becomes a minus 2 thirds right here. I don't even need to cube that anymore. All right. Anyways, all that said and done, what you wind up with is 10. There's your answer. Or, again, you could leave it like this. Okay? Either one's okay. Let's grade this on the AP. If you knew to split it, plus 1. If you took the antiderivative, plus 1. And the answer is also plus 1. All right, for part C, between negative 5 and 6, on what open intervals is the graph both positive, increasing, and concave up? Well, increasing is saying that the derivative, that f prime, which is g, has to be 0. We're looking for critical numbers. And concave up, it's our second derivative. So f double prime, which is g prime, has to be 0. So these are your possible points of inflection. And of course, these are your critical numbers. So first of all, let's deal with the critical numbers, where the derivative of f, which is g, equals to 0. And we can find those on the graph, where now we're looking here at the values. And of course, what do those values equal 0? Let's be from negative 1 to 0, that whole domain, negative 1 to 0, and at 4. So these are going to be, whoops, hold on, negative 1 to 0 and 4. Now let's deal with the possible points of inflection. These are where the second derivative, which is g prime, equals 0. But this time we're looking at where the slopes are equal to 0, or d and e. They can be d and e as well, don't forget, d and e. So if we go back, where does that occur at? It's kind of hard to tell. Let me erase some of this so you kind of see it better. Okay. Let's see here. All right, so let's see. It looks to be where at? Where the slopes are 0, the whole negative 5 to negative 2, negative 1 to 0, 1 to 3, and at 4. Wow, that's a lot. So let's go ahead and list them, label them. They are, what do we say? Negative 5 to negative 2, or negative 1 to 0, or 1 to 3, or at 4. This is going to be our double sign chart. There we go. On top, we're going to deal with f prime, which we now remember our domain from negative 5 to 6, which we said from, what's that, negative 1 to 0. The slope is 0. And at 4. So negative 1 to 0. And then for the concavity, so well, let's go back here and look at the slopes here. Let me get rid of this here real quickly. I don't like this right here. Since I'm only dealing with the f prime, I don't really want to worry about the negative part underneath here. It can get kind of confusing for us. So let's see here. Let me see, go back to my pen. Going back, looking at the slopes. Ready? Remember, since this is f prime, remember, here, positive slope, negative slope. So between negative 5 and negative 1, the slope is negative. So that's going to be negative. We already said this is 0. If we go back, here the slope is positive, and the positive because we're always above. So it's positive and positive. All right, now let's do the concavity. So concavity is from -5 to -2. So there's -2. From -1 to 0. Nope, and then from 1 to 3. These are all where they are. And if you know, remember, these are all where they are all 0, 0. Oops, sorry, -1 to 0. There we go. Missed one. All right, this was not 0 there. And 0 from 1 to 3. Now, remember, this is f double prime. So remember, what we're looking at here are the slopes of G. Right here. So let's go back to our graph. Remember, slope was 0, positive, 0, positive, 0, negative slope, positive slope. So it's going to go 0, positive. Let me zoom out here. Positive, 0, positive, 0. Oh, I forgot to mention 4, right? Remember 4 was 1, 2. Negative and positive. Boy, that was a hard question. There's just a lot of domains right there. Take a look at this one. Definitely try this one again. All right. So we want to know where it's positive, so what we're looking for is where the derivative is increasing, f prime is increasing, and the second derivative is positive. So we're looking for this region, somewhere where because the first derivative is positive and the second derivative is positive. And where does those occur? Well, it looks like between 0 and 1, and looks like 4 to 6. So we would say on 0 to 1 and 4 to 6 because the first is positive and the second is positive. I normally don't say box your answers. I'm just going to box this in just to make sure it stands out here a little bit, okay? And how many points will this be worth? Oh, this is a tough one right here. You get +1 for your intervals, +1 for your answer. I don't know what you, that was a tough one right there. All right, and the last one, part D, we shouldn't miss it all. Find the x-coordinate where there's a point of inflection. Ah, this is nice. This is just where, remember this one? This is just where f double prime changes signs. Okay? So let's see. Is there any place for that cares? Oh, we get up here. Where do the signs change? Now be careful between, when we say change signs, we're saying that it has to go from positive to negative. So a point like -2, even though it's positive on one side, it's 0 on the other side. There's no sign change. 0 does not have a sign attached to it. We're only looking for where it actually changes signs. And the only place that occurs for f prime is at 4. So we would say there is a POI at x equals 4, and that is because f double prime of x changes signs. Now notice, be careful, it said they're talking about f here, so leave it in terms of f. Don't do g prime, please. Okay? And that is 1 point for your answer, 1 point for your reason. And notice, we use a sign chart. This is a really tough sign chart. AP is getting a little bit tougher on the sign charts. So definitely study this one, okay? And I'll see you guys in class. We go over some more questions if you'd like, okay?